Okay, so if you're here, we're learning about magnetic separation. So one of the physical properties that materials have is that they can be attracted to magnets. And so if you have some material that's attracted to magnets in your mixture, that gives you actually a really easy way to help separate your mixture, right? So we can see here, we have some sulfur mixed in with some iron filings. Well, sulfur is not magnetic and iron is. And so if we stick a magnet into that bowl, the iron will stick to the magnet and the sulfur will stay behind. This gives us a really good way to separate these two materials, right? Instead of trying to pick out all the iron by hand, we can just use a magnet and do it very quickly. So the main thing is you want to look at your data table. If you have stuff in your mixture that is separated by a magnet, right, it'll be magnetic, and then things around it will not be magnetic. So I have in a cup here. So notice that we have iron and nickel are magnetic, and copper and sand are not. So you'll notice in my cup here that I have a mixture, and in this mixture I have glass beads, I have copper beads, and then I have some nickel beads. And so if you remember from our data table, copper is not magnetic, and we should all know that glass is not magnetic, but our data table said that nickel is magnetic. So I could pick out all those nickel beads by hand. That's one way to do it. But if I want to be efficient with my time, I can just stick a magnet in there. Okay, just try to shake it off so you get any glass or copper that got picked up, and then I can just kind of separate it out. And then notice there's still some nickel in there. So you want to do a couple of pass-throughs on your material, right? See how there's still some in there? And then just one more just to be sure. Give it a shake, really make sure. Looks like there's no more nickel. And so look at that. It took me seconds, and all of these nickel spheres are separated out from our glass and our copper. Really easy, okay? Now, another thing that we might need to separate is iron filings. That's the example they use with a sulfur. Now, with the example they use, they just stuck their magnet straight into the iron filings. We don't want to do that because it's really messy and hard to clean up, right? Let's get a magnet from here. So these magnets have been stuck in some iron filings. And so look at that magnet, right? Look at all that powdered iron on the sides there. That's a mess. If this magnet wasn't in this plastic bag, I don't want to use that one. This is a small bag. Let's use this one. You know, if this magnet was not inside this plastic bag, all that iron would be stuck to the magnet. It would be really hard to get it away from the magnet. But since it is in the bag, we're going to go ahead and try and separate this iron out. So whatever our mixture was, it had these iron filings in them. Now that we have them on our magnet covered by our bag, we just stick our fingers in there. Sorry, I got kind of big fingers here. And then we're just going to go ahead and pull the magnet up through the plastic. And then look what happens. The magnet is clean, no iron on it. And then all of our iron that was in our bag can just start falling off because there's no magnet there holding it in place, right? So let's give it kind of a shake, try to be careful with it. And look at that, just pure iron powder there, right? Really nice. And then we can, remember, always do 2, 3, 4 pass-throughs with your magnet, right? So go back to your mixture and then make sure to get more magnet mixture and just keep repeating this process until you get most, like 90% of the iron out, right? Anything that's easy to get out, okay? Another thing to think about is sometimes when you're trying to separate mixtures, some things one of your group members will tell you can dissolve in water, right? Iron doesn't dissolve in water, and you can, if it is in water, this iron powder, you can still use a magnet and it will still attract to the magnet. Look at that, right? So we got all that iron there, it's still attracted to the magnet. But notice it's messy and it's wet. And the problem with that is if you have stuff dissolved in this water, if you take that magnet and you pull that iron out and it's wet, some of your dissolved solids are going to be in your iron. So your iron's not pure anymore, okay? And even if you got all the iron out of the water, you could even stick it in the mixture, right? Check this out. We could stick this right in here. Look at all that iron on the bottom, okay? Stick it in, kind of get as much as you can, and notice what our water looks like. It's still dirty. There's still iron in here. You can't get it all out with this bag. So now we have two problems. Our iron has whatever's dissolved in the water stuck on it. So when we dry this iron off, it's not going to be pure iron. And our water it's contaminated with iron. So when we dry out this water and get whatever solids in there, that's going to be contaminated with our iron. So we have two things that are contaminated now. So make sure that if you're doing a magnetic separation, one of the most important things, make sure you talk to your group about this. One of the most important things is you don't want to do wet magnetism, right? It makes a mess, it doesn't clean up, and things aren't pure. So one of the most important things is that if you have something in your mixture that you need to pull out with a magnet, pull it out before you add any liquids, okay? That is a very important step. Second important step, make sure your magnet's always in its bag unless you need to pull it out to get the material to drop, right? And then put it back in the bag. If your magnet has iron filings on the inside, your group's gonna lose points. So you better make sure you write that down. Magnet should be clean. It stays clean inside the bag, okay?